Hi guys, this is O-Level Chemistry, paper 12, November 2021, question 11. The relative atomic mass of chlorine is 35.5. What is the mass of 2 moles of chlorine gas? So first of all, if we have 1 mole of chlorine gas, so it's Cl2, so that would be 35.5 into 2, giving us a value of 71. And the question states if we have 2 moles, so 2 moles would result in 71 being multiplied by 2, giving us a value of 142 grams. So the correct option for this question is option D. Question 12. When gases react, the volume of gaseous reactants may be different from the volume of gaseous products. For which reaction is the percentage change in the volume of gas largest? Assume each reaction goes to completion. So now in option A, we have got 2 plus 1, 3 moles of reactant going to 2 moles of reactant. So there is a decrease of 1 by 3. So a decrease of 1 by 3 in percentage would be a decrease of 33.33%. Next, option B, 1 and 2, 3 moles of reactant producing 3 moles of products. So the number of moles of reactants and products are the same. There is no change in percentage. C, 4 moles of reactants and 2 moles of products. Now 4 moles going to 2 moles is basically 2 upon 4, which is equal to 1 over 2, and this into 100 gives us a decrease of 50% in volume. And the last one, we've got 7, 8, 9. 9 moles of reactants and 6 plus 4, 10 moles of products. So 10 upon 9 into 100. This would be a value that is greater than 100%. So we've got an greater increase. There is an increase in the volume. So the question has asked us which reaction is the percentage change in the volume of the gas greatest. So out of the 4 given options, the greatest difference appears in option C, and this makes option C the correct option for this question. On a side note, if we are going to calculate the value for option D, it's going to come to 111%. So the difference would be 11%, because if we subtract 100 from 111, the difference is 11%. So there's a greater increase in volume of 11%. So this is just a side note. Our correct option has already been discussed, which is option C, because the greatest difference in volume is 50%, which is exactly half of the total volume. Question 13. Sodium carbonate reacts with dilute hydrochloric acid. Given equation. A sample contains 0.08 moles of sodium carbonate is added to a solution containing 0.1 moles of hydrochloric acid. Which volume of carbon dioxide is produced measured at room temperature and pressure? Okay, so now in this equation, moles of Na2CO3 is to moles of HCl is 1 is to 2, which means if they have 0.08 moles of Na2CO3 reacting, so the amount of HCl or the moles of HCl required would be 2 into 0.08, which will give us 0.16 moles. And this is not the value given. The value given is 0.1. So this makes HCl the limiting reactant. So now what we have to consider is that if we have 0.1 moles of HCl, how much of sodium carbonate would react? So that would be half into 0.1, which will give us 0.05 moles. So the moles of sodium carbonate reacting would be 0.05. And according to this equation, moles of sodium carbonate is equal to moles of carbon dioxide, which means moles of carbon dioxide is also equal to 0.05 moles. Now, we need to calculate the volume at room temperature and pressure. 1 mole of any gas occupies a volume of 24 dm cube. So 0.05 moles of carbon dioxide would occupy a volume of, this would be calculated as 0.05 divided by 1 multiplied by 24. And we would end up with the answer of 1.2 decimeter cube. So this makes option B the correct option for this question. Question 14. Which statement about the electrolysis of solutions is correct? During the electrolysis of concentrated aqueous sodium chloride solution, hydrogen is produced at the cathode. Yes, because hydrogen is less reactive than sodium. So it is produced at the cathode, and we would have chlorine being produced at the anode because this is a concentrated solution. So option A is correct. Now let's look at the other options and why they are incorrect. B. During the electrolysis of dilute sulfuric acid, oxygen is produced at the cathode. Oxygen is not produced at the cathode. Oxygen would be produced at the anode. Hydrogen would be produced at the cathode. So this statement is incorrect. Option C. When aqueous copper 2 sulfate is electrolyzed, the reaction takes place at the cathode is Cu positive plus electron gives Cu. No. When aqueous copper sulfate is electrolyzed, the reaction taking place would be Cu2 positive plus 2 moles of electrons giving you Cu. Copper has a charge of plus 2 as stated in the statement itself. So we would need 2 moles of electrons. So the equation given is incorrect. D. When aqueous copper 2 sulfate is electrolyzed using copper electrodes, the mass of the anode at the end of the reaction will be greater than at the beginning. Anode is where oxidation occurs. Oxidation is equal to loss of electrons. So when electrons are lost, copper would be converted into Cu2 plus. So it would lose mass during the process. So the at the end of the reaction will be lesser. The mass would not be greater, it would be lesser because mass would be lost. So this is the reason why option D is incorrect. Hence, option A is the correct option for this question. Question 15. The apparatus shown is set up to plate a steel key with copper. The key does not get coated with copper. Which change needs to be made to plate the key? Okay, increase the concentration of aqueous copper sulfate. If the key is not being coated, then changing the concentration of copper sulfate will have no effect. Increasing the voltage, same reason. If it is not getting coated, change of voltage will have no effect. Replace the solution with dilute sulfuric acid, then it will not be coated with copper at all. Reverse the electrical connections. If you can see clearly in the diagram, the positive electrode is the anode, and anode is where oxidation takes place. If the key is placed at the anode would be losing its mass, not gaining its mass. So if we reverse the connection, this would become the negative terminal, which is the cathode, and cathode is where reduction takes place. So copper ions will get reduced on the cathode, forming copper metal, and thus the key would have copper being coated onto it. So this makes option D the correct option for this question. Question 16. The equation shows the reaction of glucose with oxygen. Which statement about this reaction is correct? It can occur in the dark. This is the reverse of photosynthesis. Photosynthesis consumes carbon dioxide and water, producing glucose and oxygen, and that requires light. This is the backward reaction, so it will not require light. It can occur in the dark. So option A is correct. Now let's look at options which are wrong. Option B, it is endothermic. No. Photosynthesis is endothermic. So this is the backward reaction. This reaction is exothermic. C, it needs chlorophyll as a catalyst. No. The photosynthesis reaction needs chlorophyll as a catalyst, not the other way around. It occurs in plants but not in animals. This is oxidation of glucose, in other words, respiration. This occurs in both plants and animals. Photosynthesis does not occur in animal and it occurs only in plants. So, this process is happening in plants as well as animals, making this statement incorrect. Thus, option A is the correct option for this question. Question 17. The energy profile diagram of a chemical reaction is shown. Now, as we can see, this is an endothermic reaction profile diagram because the reactants are below the products in this profile diagram. Okay, the reaction is exothermic? No, it is endothermic. X represents the activation energy for the reaction. The activation energy is the energy from the reactant till the maximum state, which is the transition state as represented by the curve, the height of the curve. So X is actually the activation energy for this reaction. So option B is correct. Option C, Y represents delta H for the reaction. No, Y does not represent anything for the forward reaction. It could be the activation energy for the backward reaction, but it has not been stated this is a reversible reaction. So statement C becomes incorrect. D, Z represents the energy given out as the reaction proceeds. No, Z is supposed to represent the energy required. So the arrow should be pointing upwards, not downwards. So the direction of the arrow is incorrect, making option D wrong as well. So as a result, option B is the correct option for this question. Question 18. The equation shows the reaction of for the manufacture of ammonia. Okay. Which change will decrease the activation energy for the reaction? A decrease in activation energy is by the presence of a catalyst. Option A says addition of a catalyst. Option A is correct. Option B, decrease in temperature. Now, they have not stated whether this is an endothermic or an exothermic reaction, but we need to remember Haber's process is an exothermic process. So, a decrease in temperature will favor the forward reaction. It will have no effect on the activation energy. Option C, increase in concentration. If the concentration of the reactants is increased, the forward reaction is favored. If the concentration of the products is increased, the backward reaction is favored. Nothing happens to the activation energy. And D, increasing the pressure. An increase in pressure favors the side with the lesser number of moles. So as we can see, there are 4 moles of reactants and 2 moles of product. So increasing the pressure will shift the equilibrium towards the right, but it will have no effect on the activation energy. Thus, option A is the correct option for this question. Question 19. The apparatus shows a method of following the rate of the reaction between magnesium carbonate and dilute nitric acid. Equation is given. Now, the apparatus used is a conical flask with a rubber bung and a delivery tube connected to a gas syringe. And the graph shows the volume of gas collected against time. Okay. Three statements are made about the experiment. Statement one, the mass of the flask and its contents decreases as time increases. Yes, because some of it is lost as CO2, which is collected in the gas syringe. So the statement one is correct. Statement two, the rate of the reaction decreases as time increases. Yes, this is seen in the graph. Look at the volume of gas collected. Initially, the volume of gas is increasing, but as time progresses, the curve gains a plateau region. So the rate of reaction decreases as time increases. And three, the reaction has finished after 4 minutes. So 4 minutes, we can see that whatever the volume is at 4 minutes, the volume remains the same after 4 minutes. So the reaction has finished after 4 minutes. Yes, this statement is also correct. Because all three statements are correct, option A is the correct option for this question. Question 20. Aqueous bromine is added to aqueous sodium chloride. Okay, which statement is correct? Bromine is oxidized and chloride ions are reduced. So if we have NaCl reacting with Br2. Now, bromine cannot displace chlorine in NaCl, so this reaction will not happen. So, A becomes incorrect. B, bromine is reduced and chloride ions are oxidized. No, reaction is not happening. C, neither oxidation or reduction takes place. Yes, nothing takes place actually. D, sodium ions are oxidized. No. Bromine is less reactive than chlorine, so it will not displace chlorine from its solution of salt. So neither oxidation nor reduction is taking place. In fact, there is no reaction occurring. This makes option C the correct option for this question.